Hi everybody, haven't seen you guys in a long time. In case you're wondering, I'm doing okay. My arm's just a little bit wrapped up right now, but not in too much pain. Anyway, today we're working on proportionality theorems, and a lot of really interesting theorems that come up in this chapter, so let's give them a look. So the first one, we're learning about the triangle proportionality theorem and their converse. Its converse. And what the theorem says is if we have if a line inside a triangle is parallel to the opposite side, then it divides those two sides proportionally. So in this case, TU and QS are parallel. The proportion RT over TQ will be equal to RU over US. And the converse of that is also true, implying that if the two sides are divided proportionally, then the line that divides them is parallel to the third side. So these turn out pretty useful. So let's give it a shot. So we look over here, and it says, all right, QS and UT are parallel, which means that these sides are divided proportionally. So that means that 4 over 6 equals, call that x over 9. This one will cross multiply, we get 36 equals 6x, and x equals 6. So that means RQ equals 6. That one's not so bad, it's pretty easy. Alright, give the video a pause. Why don't you find the length of YZ? So first thing we got to do is we set up our proportion. So we say xw over wv equals xy over zy, or yz, whatever. So 44 over 35 equals 36 over yz. Cross multiply, and we get yz equals 1260 over 44. We divide by 4, we get 315 over 11, which is somewhere around 28, if you work that out in the calculator. Alright, hopefully you got that. Let's move on. So since the converse and the conditional statement are true, it also means the contrapositive and the inverse are true. So if we get that the sides are not in proportion, then the lines aren't parallel. And similarly, if the lines aren't parallel, the sides won't be in proportion. So let's put that to use. So we got this shoe rack over here, and they tell us that BA is 33 centimeters, CB is 27 centimeters, and CD is 44 centimeters. You guys probably can't see that. And DE is 25 centimeters. And they're saying, why isn't this parallel to the floor? Well, if these numbers aren't going to be in proportion, then it won't be parallel. So let's check. We do 27 over 33 equals 44 over 25. A couple ways we can do this. We can just simplify the fractions. If we get the same thing, we're done. Or we cross multiply. So I'm going to simplify and then cross multiply. I think that's going to be the easiest. So divide both these by 3. And I get 9 and 11. So 11 times 44 is 484. And 9 times 25 is, oh, this isn't even close. This is 225. Yeah, so this is way off. And it's pretty clear that that's why. Since these aren't in proportion, the shelf's not parallel. Alright, so remember that when you're building. Alright, let's give you guys a try at this. Determine if this PS is parallel to QR. Pause your video, so will I. So we set up our proportion, NP over PQ equals NS over SR. And they both simplify to 9 to 5. And since those are the same ratio, same proportion, then we know the lines are parallel. Alright, so I like actually the simplifying better. If we go back to that last example, it's pretty obvious this doesn't simplify, so we knew right away. But cross products works as well. Okay. So we're going to take a look at a construction now. The one in the book's a little different, and I actually think it's easier. But I just want to show you another way to do a constructed line segment. All right. all we're really trying to do here is make 4 sections. Since the ratio is going to be 3 to 1, we want to make 4 sections, and the third one's going to be congruent. All right. The one we're going to look at is through my website. There's that link for lines, and it says divide a line segment into n equal segments. So if we click on that one, what they do is they first just draw a line segment and then draw another segment. All right, so just a line going across. And what they're going to do is they're just going to make, in this case, they're dividing it into 5 equal segments. So they're going to make 5 arcs of the same length. 2, 3, 4, and 5. All right. Now they're going to connect that distance. They're going to draw the same exact distance from point A, and they're going to figure out the length of AC and copy that length to BC. So they've essentially made 2 parallel lines here. Once they connect it, where AB sort of acts like the transversal. So now they're going to make those same exact arcs on the other side. So now like these segments and these segments are going to be congruent in length. 1, 2, 3, 4, 5. And now they're just connecting 1, 2, 3, 4, and then I don't know if you guys can see it, but this point C over here down to B, it's 1, 2, 3, 4, 5. This was 5 congruent segments, so you could say this would be 2 to 3, or 3 to 2, or 4 to 1, or 1 to 4. The key is just to make it into the right amount of congruent segments. Alright, back to the lesson. So there's another theorem. If we have 3 parallel lines, R, S, and T, and they divide 2 transversals, they divide it proportionally. So it's kind of like the last one with the triangles. So what this means is UW over Y over WY is going to be equal to VX over XZ. All right, so let's try to use that. So if we look, since angle 1, angle 2, angle 3 are all congruent, and they're all corresponding angles, that means HC is parallel to GD is parallel to FE. So these 3 like horizontal lines are all parallel. And that allows us to use the last theorem. So when we do this, that means this part and this part are proportional to this part and this part. So we could say 150 over 300 equals 120 over GH. Alright, and we want to find HF, so we're just going to add them up when we're done. So the first thing I do is I'm going to simplify, and this is actually really nice simplifying. This is 1 to 2. So we get GH equals 240 yards. Oops, I wrote that very poorly. Let's try it again. GH equals 200. There we go, 40 yards. We add that to 120, and we get HF equals 360 yards. That one wasn't so bad. Alright, the last one is a triangle bisecting theorem. I like this one a lot. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of sides. So it'll divide like AD in proportion to AC and DB in proportion to CB. Alright, so what it says is AD over DB, top over bottom, I guess, equals CA over CB, top over bottom, but it depends how it's laid out. Let's put that to use. So if we look here, we have this triangle, and angle P is bisected. So what we know is that this length over this length is equal to 7 over 13. So this length here, QR, is going to be 15 minus X. So since this is X and this whole thing's 15, this is the difference, 15 minus X. So 15 minus X over X equals, and then just 7 over 13. Do our cross products, we get 7x equals, let's see, 15 times 13 is 1, I believe 195. Let's see, 10 times 15 is 150, 3 times 15 is 45, so 150 plus 45 is 195, minus 13x. Alright, let's add 13x to both sides. We get 20x equals 195. Oops, 195. And we divide both sides by 20. And we get x equals, we can simplify that by 5. That'll be 4. That'll be 19. No, I'm sorry. Yeah, divide by 5 would be 19. No, I'm sorry. Oh, goodness. Alright. So 20 goes into 195. Let's do a long division. Sorry about that, guys. 20, 195. I know 10 would be too many, so this would be 9. This is 180. We get 15 left over. Decimal point 0, decimal point 0. Oh. So we get 150. This goes 7 times. And move you out of the way. We get 140. We get, oops. Anyway, what did I do? There we go. So we get 140, subtract 10, bring down another 0, and 5. So we got x equals 9.75. Sorry about that work, everybody. But yeah, either way, that's what we're looking for. So I'm going to scroll down. I got 4 problems for you. When you give those a shot, pause it, and we'll be right back to explain. Alright, so again, corresponding angles. So this line, this line, this line are parallel, which means they divide these transversals proportionally. 16 over 40 equals BD over 30. And when we cross multiply and solve, we get 48 equals 40 BD, and we get BD is 12 units. Number 12, again, these are all right angles, so again, corresponding angles congruent. These lines are parallel. It means 15 over 18 will equal 16 over JM. We cross multiply, we get 288 equals 15 JM. And we divide 288 by 15, we get 19.2 units. And that's going to happen. You're not going to always get integer units. Now here we have angle bisected, which means it divides these sides proportionally. So we get 24 over 48 equals 14 over x. And that's when you could simplify if you felt like it. This is 1/2. So this would be times 2. But either way we do it, we get 28 units for TU. Now here we have a special right triangle, 4 root 2. So 4, 4, 4 root 2, and y is also going to be 4 root 2. Since these are the same, these will be same because that's going to make the proportion. It would look 4 root 2 over y equals 4 over 4. Cross multiply and divide, we'll get 4 root 2 again. Alright, so hope you enjoyed the lesson. I will see you in class. Bye-bye.